Well, hello and welcome to everyone to this lesson. We're going to be looking today at how to write views for Sage CRM. Now, this is a new lesson within the developer cycle, so it's designed to fit in to the existing series of 18 lessons which form the main development partner lessons, and these additional lessons, and this first one is one of three that are designed to fill in some of the gaps in people's knowledge. And the idea here is that before we rush on and start discussing the importance of entities and views to Sage CRM, we should actually look at the idea of how views are constructed generally, and then we can reiterate some of those concepts in a little bit more of a sophisticated way. And the purpose of this lesson is so that really anyone who is involved in Sage CRM should feel much more confident about coming in and starting to customize views, which underlie so many different features within Sage CRM. If you think about something as diverse as a mail merge or a group or a port, or in fact, if you think about some of the dashboard gadgets that you might want to include, they essentially need to be based on views. And so in order to be able to do anything beyond the most simple customization of maybe changing the order of a field within a screen, we need to be able to construct views. And this is where this particular course comes into it. Now, across the session, the 90 minutes or so that make up this particular lesson, we're going to be covering a number of different topics. We're going to be looking at where views are used inside Sage CRM. We're going to look, of course, at the basic structure of a view. We'll also consider not only the basic structure of a view anyway, but we'll also think about how the views are structured within Sage CRM. We'll look at the different forms of documentation that are available and where we go for help, and start to think about the idea of defining a view safely. So there is a very particular way in which we would approach the definition of a view within Sage CRM that avoids any problems and any difficulties from a support perspective. We'll look at how we can take an existing view, how we can then change it, and really start to change it in quite a sophisticated way. So not just adding in another field, but really the idea of taking a series of fields and maybe carrying out some concatenations on them or a calculation to derive and produce new information as from the basis of the underlying view. We will use all the way through the basic tools that Sage CRM provides us, plus we'll use the native database tools to make sure that we are getting the best use of the tools available to us, so that we actually do the minimum amount of thinking and the maximum amount of actually applying what our business or our organization needs. And all through this, we are going to be mindful of the amount of knowledge that we have, so that we can exercise discretion when it comes to requesting help. So we'll look at areas where we might need to go off and speak to a specialist system administrator or a database administrator and get help from them. Now, that's the overall agenda. And putting into sort of context, and this is a type of introduction to SQL, but specifically it's going to be looking at the construction of views. Now, SQL falls into two broad categories. There are some things that it's used for, such as data definition. So the actual language of SQL can be used to construct tables, to alter columns within a table, even to construct the views that we're going to be using today or looking at today. But what we're not going to be doing is we're not going to be looking at that because a lot of the data definition is going to be carried out entirely through the interface of Sage CRM. And what we will be doing instead is concentrating on the aspect of Sage CRM known as data manipulation language, which is all about the interaction with the underlying table. But even with there are some things that we're not going to cover. So although we're not going to cover, for example, the process of creating and altering views, that's something that takes place entirely within Sage CRM, neither within data manipulation are we going to carry out inserting, updating, and deleting data. And this is because views within Sage CRM, essentially, we are going to be focused on trying to keep things as straightforward as possible. Insert, update, and delete most situations require us to use the underlying base table. And we have API mechanisms that allow us to do the interaction with those underlying tables. But the views require us to select information and to bring information from the database, from multiple database tables, into a single data source. And that's what we'll be concentrating on. But we can become quite complex in our usage of SQL. And I'm going to be using, throughout this lesson, I'm going to be using the query server management, SQL Server Management Studio. So if I log on here, one of the things that we're going to look at is carrying out queries against the database. Here I'm going to use my instance of CRM, which happens to use the database called Sage CRM or CRM 7.3 or 7.3. And if I have a look down, if I have a look down at the table custom views, and I'll explain a little bit more about the structure of SQL statements in a moment, but here I'm selecting all columns from the underlying table custom views. What we will see is that this table is the place inside Sage CRM in which the definitions of the different views are stored. And as we go through and start looking at this, we will look at the contents of the field view script, because view script allows us to look at the different types of clauses that are used inside Sage CRM. So in fact, you've got something in Sage CRM, this table, we've got 414 views. Most of those views are not going to use structures like having or group by, and consequently, although I will touch on them, I am not going to cover them within this training class because it is not a common user feature to use the having and group by aspects of complex SQL clauses. Now, all of that raises the question of why are we going to work in a particular way? And one of the reasons why we are not going to work in a particular way is because Sage CRM nearly always changes the SQL that you've written. So if you go down the route of defining in your view, for example, an order by statement, what you'll find is if that view is used in the context of a list, you'll have CRM trying to automatically apply an order by statement anyway. And that's something that we'll look at in a little bit more. Now, I realize that right now I've already started to use jargon. And one of the difficult things about talking about SQL is that you actually have to talk about SQL using SQL, and we're introducing these terms almost implicitly. Now, I have made the assumption in all of this is in that you are familiar with the features of Sage CRM and you have used things like the mail merge feature, and you have used the group feature, and you have used saved searches. And so this sense that CRM is pulling in information from different sources should be completely familiar with you. Now, the underlying SQL that the views use, I think, is relatively easy to learn. The full language of SQL probably has a vocabulary of less than 100 words, and we're only going to be using maybe about 50 words at max. And that's including the different functions that I will use, but the core language of using select and in, between and from, group by, and etc. There's only about 100 words, and we'll use far fewer than those in this particular lesson. So it should be very easy to pick up. And also, one of the things about it is that we're not having to worry about logic that is procedural in nature. This is what we mean by a non-procedural language. We're not dealing with if, then, else type behavior. We're just asking, is this the case? Is this the case? This is the view. So we don't have to be too worried about it. And the nice thing about is when we come to searching for help, although we're going to see in a moment that we're using essentially one particular variety of SQL in all that we do, if I ask for if I ask a question about using the group by clause in SQL, what you'll see is that nearly any of the help results that come up when you search for this within Google will be useful to you, whether this is focused on the database that we're using or not, because SQL is a standard language governed, its core language is governed by a set of ANSI standards, ANSI standards. Now, I did mention that several SQL dialects exist, and if you were around in version 7.1, then you would have at least had to have known 2 of SQL standards because of the use of SQLite for the solo feature. Well, solo is not supported anymore. It's not within the product, and nowadays we only have to worry about one database variety. From 7.3, even the support for Oracle has been withdrawn. We came to an end of life support statement associated with the release of 7.3 on that. Now that means that we know that we can focus our look for documentation and assistance on a single database, and that is applicable for when it comes to thinking about the version that we're using. Now, Sage CRM has a narrow range of officially supported languages, versions of SQL Server. I do want to distinguish, however, you can see that here that, for example, support for SQL Server 2008 R2 has been dropped. But I would point out that if I go on and look at the database that I'm using at the moment, you can see here I am using, for development purposes, or my own training and testing purposes, I'm still using SQL Server 2008 on my machine. Now, that's fine. You know, it really isn't a problem for us because the types of SQL that we use within Sage CRM are relatively straightforward. So we're using quite a narrow range of behavior and functions, and we don't have to be overly complex about the usage, though I would hasten to add, within a support environment of a live system, this is the production server, you have to stick to the supported versions of SQL Server, and I would ask you to check the support matrix to make sure that for the particular patch status that you're on for 7.3, that you are working with the correct versions of the database. Now, stating something that is an obvious statement for those people who are used to working with databases, CRM has to use SQL for all of the interactions with the underlying database. It's obvious for those people who are used to working with relational database management systems. It's not so obvious if you have come from an object database environment or a flat file database environment, or one in which there are direct programmatic mechanisms which allow us to change and interact with the data. Here we are working in an environment where we have essentially one mechanism for passing in commands to the database. Even eventually when we come to doing the programming work that we're doing using the COM API and the .NET API and web services, we will see within the logs that ultimately it is SQL that is being passed to the database, and it is therefore the underlying database's own functions that we're using. Now, in all of the interactions that we're going to be doing, we're going to be using SQL Server, and that means not only can we use the core SQL standard, but we can also use the vendor-specific SQL as well. And that means that we can be confident about using the functions like getDate and the dateDiff and the way in which concatenation works. So we work in a way for the underlying database. Now, it is important to double check any of the database support, as I said, with the support matrix, but essentially you can be fairly confident within a SQL Server that in a development or a testing environment, we support, or it is possible to use a wider range of varieties of database versions of SQL Server other than the ones which are formally supported for production environments. Can I state that when we have a support statement, it is entirely to do with the production environments that we support. Now, one of the things that we can do is either use the tools here inside the database to trace the actual database queries that are happening, or we can log on into CRM and make sure that we use logging. So you can see I'm just logging on into CRM, and while that's starting up, I'll step on to the next slide. The logs are our best friend when it comes to starting to understand the interaction within the database for SQL Server and the views. We have here, let me just see this finish off. So if I go in here to go into administration and come down into system and into logging, we can see in my case I've already turned on logging, and we should see that we're logging all queries over the threshold. So let's double check that and see what that means for us. If I go into the system and log on as a user, Susan May, I'm going to click on this opportunities tab in a moment. Now I'm going to open up the existing SQL log, and this is actually the path for today's log. I was looking at this earlier on. If I save that, this is a blank log. And now within my interface, I'm going to click on the Opportunities tab. And so we see the SQL has fired. Now a whole range of different SQL statements are fired. A lot of this is to do with the first time that this particular user has accessed the screen, and that because this user represents a particular translation family, uses a particular language, there's a lot of captions being cached into memory. But the thing that the two lines that I'm interested in here are these two lines, which represent where the data from the view is obtained. This is actually the view that sits behind this particular loop, the group that says that there are 10 opportunities here, and there are showing 10 opportunities on this screen. And what we can see is that we're using and running an SQL statement against the vList opportunity. If I examine vList opportunity, and in both cases, by the way, these two statements are using vList opportunity. If I go into the administration screens, in here I need to log off. Actually, I was logged on already as a system administrator. I just need to use the right screen. If I go into the opportunity page, look at the views, and look at the view vList opportunity, somewhere in here, vList opportunity, we can see it's a straightforward view. Admittedly, you might not feel too comfortable with looking at it at the moment, but I can assure you that as we look down through here, essentially it's joining a few tables together, it's pulling columns back, but none of the information that's being pulled back is focused on ordering. There's no order by statement in this query. If we look at the SQL that was generated, we can see that our generated query is providing order by statements. Sage CRM changes the SQL that we write to apply its own rules, and consequently there are some challenges with using particular clauses, and these are the clauses that I'll mention again in a moment, and I'll mention them again now. Order by, group by, having are things which are not commonly used within views because Sage CRM changes and the SQL that is generated, and it's the logs that allow us to see what's going on. And it's worth just spending some time looking at what's generated. Now, views underlie just about everything within Sage CRM. Hopefully you can understand that if I was to go into the database and look down here at what we've got, I've got a database called Sage CRM 7.3. This is the underlying database for the system, and within the database there are the different tables. And I can look at a table within the database, like company, and know that I'm pulling the straight information back from that entity. But if we think about the wider sense of this company, the thing that it's representing in the real world, is that company is likely to have a bricks and mortar address. It's likely to have contacts that we're needing to deal with. And consequently, on its own, the company is insufficient. We need to be able to join and bring the related information from the person and the address and the phone and the email together. And this is the idea of a view, allowing us to assemble a virtual table dynamically when it's requested, so that it brings all of the information that the user needs into the one place. Now, no data is actually stored. This is simply a dynamic view on the information. Instead, there's a definition of how that data is pulled together. And the data always comes from the underlying base table. and essentially we pull the information together using a form of data manipulation statement as a select on those base tables. So it's defined ultimately as a select statement. Now, everywhere we go, we are using different views because our understanding of the different aspects of Sage CRM are going to be different in different places. So as we work with security, we will need to have a different definition, and so the view will be different. As we work with workflow and work with data upload or reporting or groups, so different views are applied. And in the case of reporting and groups, we can define our own structures to be used. And views are so important because they underlie the way in which we start to program and work with the system. If I think about the customization of this particular screen, if I log on as Susan May and we see that we come straight in and look at this page that we're on, this is this Panoply contacts page that we're on, we can see that this happens to be a Panoply list entity called by .NET, and it's using the .NET function in here. So this is actually a bit of customization that I've carried out in my system. And underlying that list of records that actually come from another database entirely. So this is not even a view that is pulling information back from Sage CRM, but this is from another database. What we see here is a mechanism by which the views provide us, for coding purposes, the information that we need, both to the actual base tables that we need, but also to extend this concept of context. If I jump to one of the records that I've used before, so if I jump across to this case, this customer service request, here you can understand that if we were in this page now, looking at wanting to do work with any of these fields, for example, if I was to think about adding some changes, if I selected a different service level agreement, because of the context that we're in, we have access to not only the case information, but also the company and the person information. But we only have that contextual information because underlying this, there has been an SQL statement that brings that information together. Now, I do want to emphasize is that it's not just a question of views underlying system screens that we see them here, or even underlying, as I selected earlier, the idea of this Panoply contacts and some code that we might write. But it also extends to the metadata definitions which are used for the mobile interfaces as well. So views provide us with all of the sources that bring that information in. Now, it can be as complex as we like, or it can be simple. But the overriding requirement when it comes to the definition of our own views is, what is this for? What data do we need? And when we come to that point of thinking, I need to create a new, I need to create a new gadget that will show me the users that are currently logged on into my system. What I need to do is I need to define a view that will bring the appropriate data into the system. We can be as complex as we like, but it's not about complex views or simplicity. It's about appropriateness, and we need to know what we need for escalation reports and groups. So familiarity with data is the key thing, and being clear about the question that we're asking is also a valuable precursor to defining our view. Now, there's all sorts of examples that we can use, and if I go into the community and just have a look at the idea of current logged on users, and we should be able to see that there's an option in here in the blogs somewhere, and there we are. Building an S-Data gadget to view current users. This is actually a nice little gadget that will show you who's currently in the system. This was originally built, I think, for version 7.1, but it's still valid, and it's all about building an appropriate view, which we can then use as a data source for our underlying interactive dashboard. So you can't say that that's a particularly complex piece of SQL. Now, I'm going to develop these ideas still a little bit further, because at this stage, you're probably not even at the stage of wanting to write a bit of SQL. And what I do need to say is that I'm going to be showing you a whole variety of different tools, but you must always remember to only add or edit database views that are used for Sage CRM within the Sage CRM interface. Now, one of the things I'm going to do is come into the SQL Server environment, and I'm going to encourage you in a moment to go into views, and I'm going to encourage you to right mouse click and say create new view. And we'll be looking at creating a new view. But, and it's a massive but, you are not to save and to create the views in this mechanism through here. You must only create your views by going in as the administrator into the administration area, into customization, into looking at the opportunity, if it's an opportunity view, clicking on views and creating a new view through this screen. You only edit or create views through the interface. Seriously, if you don't, we're talking about if you edit your views outside of Sage CRM, directly in the database, we are talking about shifting tectonic plates, California disappearing into the sea, weeping ashes, basically embarrassed telephone calls to support asking them for help. You must create your views entirely through the Sage CRM interface. So although I'll show you this trick in a moment, only do it through here. So we'll be doing a lot of partial definitions in one interface and then pasting them into here as the trick. I'm just going to double check to see if no statements, no horrified statements have come out from my illustrations that I've just used there. Good. No questions so far. Nobody is objecting to what I've just said. So nobody from California then, I guess. Yes, Michelle, you're doing the right thing. If you develop the views in Management Studio and then copy them into Sage CRM, and then that's good. Yeah, you don't do any more than that. Now, a view is a virtual table. The process of creating a view couldn't be more simple, and we can include in our view all of the standard structures that we would expect within a select statement. So we will contain references to the tables, the columns that we want. We can compute or derive anything that we want. We can alias anything that we want, and we can aggregate in any way. We'll gradually build up some examples as we're going through this, but ultimately the base tables on which the view is based are the source where the data resides. If we want to use a view, and we're going to use a view, there are some real strong reasons why Sage CRM uses views as opposed to just interacts directly with the tables. Because of course I could, and you can imagine if I go into here Query Analyzer and I in the Management Studio, I could say select star from company. I don't have to say the company PE as the basis of my view. In fact, V company PE is one of the core views of Sage CRM. It's one of the things that is used fundamentally within the system. And we use views because they simplify what we're looking for. They do an enormous amount of simplification. They also, because they allow us to specify exactly what is and isn't within the query, it simplifies aspects of application security. Within Sage CRM, that has a special bearing because much of what we write is then dynamically changed because of the security policies. And I will be talking much more about that in 2 lessons' time. It allows us as well to derive or calculate data, and it also means that because it's not a cached store or a duplicate of the information, we're always going against the latest table data, and it means that we don't have to denormalize or use up any more space. But of course, we're asking a question of the database that is one step removed away from the actual database table. So there is an element of processing time each time we reference a view rather than directly against the table. And because a view is likely to touch on more than one table, we not only do we have the problem of indexing for one of the base tables, we also have a multiplier effect of dealing with indexing across each table that is referenced within the view. So one of the areas that you will need to make sure that you're comfortable with is knowing who to ask for help around performance tuning. And it's one of the biggest causes of perceived performance issues inside a Sage CRM implementation. If somebody is complaining Sage CRM is running slowly, it's probably not Sage CRM that's running slowly. It's probably the queries against particular tables that are running slowly. You can imagine that if, for example, you are storing lots of different communications a day, over the course of a week or a month, you may get hundreds or thousands of transactions being entered into the database, thousands of communications a week, which over the month, when you're searching for past records and information, if you've not made sure that the indexing, the way in which the database understands how to retrieve data from a particular table works, then there could be a performance question around that area. And so performance tuning is something that you need to research. And if I go to the community again and look in the community, there should be guides available to us. And I think here, if we look at the blogs you can see I've done some aspects about this, but I actually want here there are resources available on the community within the files that allow us to perform some checks as well. We're looking at here at some documents on how we make sure that we're working with the fastest database system that we need. So let's get going. Let's start to construct our views. And in this, I'm going to work on select, wheres, and group bys. Earlier on, I was talking about core views, which are in the system default views. And there is a table that we would use, which is custom views. And it's worth knowing this so you can just start to prove to yourself and research how particular approaches are made. So, for example, in a little bit, we're going to be looking at questions about whether the keyword like is used in a view. If I go and look inside here, I can see where like is used. Now, I will ironically, I have to use like for that. You can start to see which views make use of things, including whether functions like group by are used within Sage CRM. If you look down certain views where they're used, they're not the common views that you and I would normally want to change. Anything focused on core opportunity information, they're mostly about campaigns. And if you look at having, for example, as another keyword, these are not common. And you can see that by default, having is not used inside the system. So there are a number of different key structures within a select statement, like group by, having, and order by, which are not commonly used, and consequently I'm not going to be I may mention them a little bit more depending on the questions that come in, but really I'm going to stick with the default techniques that are used by Sage CRM. Okay, now how do we start to process something? If I look at not this particular statement, but if I create a new statement and say I'm using the correct database, and now I say select star from company where comp type equals customer. The way that this breaks down is that the first thing that is looked at and processed is the from statement. This makes sure that the database query is going to be projected over the correct tables. We then apply the restriction. And the restriction is the brake or the throttle that narrows down the data that needs to be returned. And the last thing that is processed is actually the select statement itself. So here, the select statement is just using a wildcard to say, give me everything from this particular table. But it's the table that is identified first of all, then the where clause, and then finally the select statement. And we can see that that's the order in which the statements are processed. And that has a bearing in that we have to really get the from and the join correct to make sure that our database queries perform in the best way. And if we're going to start to write a database query, we can start either, as I've done here, by writing my SQL from scratch, or I could admit and say I actually don't know how to write SQL. And if you don't know how to write SQL, the place to start is actually the system views. And so I've come into system views, or sorry, not system views, into views, and choose to create a new view and choose the table in which you're principally focused. So in this case, if I just want to find all opportunities that are less than 100, so if I look for opportunities, I come down, choose my opportunity, and I might be interested in just pulling back everything from these opportunities. So I'm retrieving all columns, but I want to narrow this down so that the forecast is less than 100. I'm going to be using an arithmetic comparison here. I'll talk more about those in a moment, but here you can see that because I've started to include it, it thinks that I'm including it within the select statement. One of the rules is that a column can only appear once in the select statement because there can't be any confusion. So it's now suggesting an expression, an alias, as the value that it will be returned as. Now in this particular case, I'm not doing that because I don't want to output it. So I turn that off. What I do want to do is use and apply a filter. So this type of structure that I'm doing here is called query by example. So I'm saying that I want it to be less than 100, and you can see that it's written my where clause. So this is really very simple. I'm saying all columns from opportunity where the forecast is less than 100. And if I run that, we can see that that query works fine. This next step comes to how do I actually use this query that I've constructed to define my first view? Well, we come into the structure of our screen where I'm looking at my opportunities. I come into my opportunity views and choose to create a new view, and I need to provide it with a name. So V, I'm going to call this small stuff, and you can see that it started to build the query definition language which would create the underlying view. Now we don't actually run that directly ourselves, we get CRM to do that, but I need to get the SQL statement right. So I can bring across the SQL statement that I used, and you can see that I've pasted this in. Now if I just compare the two bits, the originating one, you can see is written all in uppercase. Now if I paste in the new one, it's the keywords are written in uppercase, but the tables and the data are written in mixed case. It really doesn't matter. I could have written all of this in lowercase because the underlying database in SQL Server is not case sensitive. You will potentially run into challenges when you are creating a cross-database view where your database that you're trying to construct a view for, and that could be an X3 database or a pervasive database or a I'm trying to think of the name that the Sage 100 database is, which are case sensitive. And you just need to make sure that you've got the correct object names. Where we've got things like this DBO in front of it, we don't have to worry about that. That stands for database owner, and it's part of the qualified name of the object. And it's good practice to have that, although it's not essential, as you could see from the original SQL that it represented. But here I've put my database object in there, and I can choose save. I'm going to say I want to add this as my reports view and choose save. That SQL would then be turned into my view statement. And what happens there is the view is created And if it had already been in existence, it would have been dropped and recreated. And these take precedence. Anything in these screens take precedence for anything you may have done inside the system. So what I was saying about earlier about tectonic plates shifting and California disappearing into the screen and earthquakes and fires and all sorts of disasters. If you have changed outside a view and somebody causes the views to be restarted and reset with inside Sage CRM, and that can be as little as someone ordering a metadata reset or carrying out the installation of a component, your view will be blown away and the existing definition used with inside Sage CRM would be used to replace it. So it could create a very severe mismatch between what you think is inside the view and what Sage CRM returns that to, because it sticks to its definitions held in metadata. Well, that's a very simple example. And I used there a less than operator as my arithmetic operator. This is an example of all sorts of comparison operators that exist. Does it equal this? Is it not equal to this? And there are a couple of variants of saying it's not equal to things. But we've also got the greater than, less than, or equal to, etc. And you've got these mechanisms that you can use. They're very similar to some of the comparisons that we can make in other languages like JavaScript as well. But there is some other important areas that we need to understand when it comes to pulling back data. One of the common fields that you'll see mentioned inside the system is the idea of the null. If I look at my definition of a view, it will typically, and then we'll see this in the V company view. If I go into customization V company PE, which is the main system view for pulling back company information, so V company PE, what we see here is that the last statement in here is a where clause that makes sure that we're not pulling back deleted information. This is an extremely valuable thing to do. And if I start to explain about the way in which nulls are used by looking at, for example, some existing opportunities, one of the things that we need to understand about null is that null can never be compared with anything else. It's just not a value. It's not a value, so it cannot be. You cannot compare nothing with a value, because we're not even talking about a value, we're talking about the absence of a value. And if we look at the opportunity table, we can see that in here I've actually got a field called opportunity reference ID. I should have somewhere in here. I'll stick with customer ref. So we've got lots of different fields about customer ref. So if I say where oppo underscore customer ref, and I can use a comparison, the most obvious comparison of saying equals, and I can say I'm interested in K2 or COT SM2, and I can pull back and retrieve the information. That customer reference exists. Now, if I look at a blank record, we'll see that that also exists. We've got quite a few who have blank customer reference IDs, but these are not quite null. customer reference IDs. Nulls, and if we look at, you can see here on here, we've got opportunity closed, indicating a lot of nulls, means that there is not an empty string. This represents data that was a string but has since been set to be nothing but not null. A bit hard to get your head around, but the null represents a complete absence of information. And if I need to look at things, I cannot say equals null. That just is not a way of retrieving it. I can't even say equals null as using the keyword. What I have to do is use a formula of saying, does this have no value, and is null and is not null, which is the negation, allows us to pull back the information that we're interested in. And so here you can see these are all the records in which the customer reference is truly null. And if I look to the flip side, is not null, then I can pull back the information in which information is absent. So we can see that this is where the customer reference is not empty. Okay, so we can see down there. That's in the structure, and you'll see most commonly nulls being used there, but we will also meet the importance of null when we come on to looking at our when we come on to looking at escalation rules, and we'll see the importance of the evaluation of fields as being null in an important area around trigger clauses and what are called stop clauses within escalation rules. An area in which we can start to develop this is, as I said, escalation rules, and I'll actually come on to that a little bit further. So I'm going to step beyond that. I'll mention that when we come on to the lessons in two sessions' time. One of the forms that we're going to discover is if we want to reference something inside Sage CRM, we can alias it. Now, I can alias in a number of ways. If I go back into my views here, clear this out, and I go and say I want to add a table as my company table. So I'm looking down into company, and I'm interested in just two columns, the company name and the company type. We can see there I have my company type. I can alias this information if I want to. I can say in here, I can call this type, and you can see that it writes it as type. I don't have to put it in quotes or anything like that, because it just ignores the idea of those. If I try and use double quotes as well, it ignores that as well, because the SQL Server doesn't use quoting as its basis, except if you want to use a spaced alias. And if I say, and call this company type, now what you'll see is that it writes it using the square brackets. Now, we're going to see this idea of aliasing in a little bit in some of the ways in which views are defined to allow us to swiftly represent both columns and also tables, because the table itself can be aliased. So here, for example, if I get rid of that and just put select star for the moment. You can see, let's get rid of that and do this once more. Table, company. I close that, and if I look at the way in which I've referenced the star, do you notice how it's looking at db.company.star? But if I put a reference for my table, I can then change this so that I'm looking at an aliased table for all of those columns. Now in this case it wants to expand out all of those fields so that they are applied and they belong to the table C, and you can see that it understands this. I don't have to specify any other table. I don't have to use C dot, simply because it understands everything comes from the same table that we've got. But that idea of aliasing, providing either an alternative column name or a table name, can be used within views. Typically, we'll see aliasing in a column where we have got a derived field, and typically we will see aliasing within a table name where we've got a slightly more complex structure. Now we'll build up to this idea of aliasing in a moment, because I want to think about the idea of aggregation and expressions. If we just think about some of these functions that can take place, there are a lot of SQL that is generated automatically within the system. We saw here, for example, where we've got a list block, the SQL is changed to automatically include a select star or a select count star to work out how many rows are being returned at that moment, which is good. You know, that's good. But it does raise the question, can you use count in the underlying query, in this case v list opportunity, if we wanted to? Now the answer to that is yes, we can, because if we go and have a look at our example of this CView script and look for the phrase count, what we will find, I've just chosen the wrong button there, if we execute that, we can see that it's used in a number of different places. And one VUse activity summary is quite a nice little view. We can see that in this case, if I go into CRM and look at the activity table, and see that we've got VUser activity summary, and we can see how the count is being used. And we can also see that since we want to return the value of this information, then we are counting it as well. And this is an example as well in this particular instance of it being used with a group by statement. Now normally, however, and this is the careful thing, is that normally the types of views that we use most commonly for reports, most commonly for groups, would not include a group by statement and therefore would not include the aggregate statement. And another part of the reason for this is if we look at the core functions of Sage CRM, if I go off into my CRM, or like actually into the report definitions, if I go into general and think about creating for myself a new report. When we look down and we're looking at the source views, and we've chosen whichever one that we want to use, like user activity summary, what you'll notice is that we then have a further way of adding group by behavior to that particular SQL. So we, most of the time, in the circumstances where we might want group by behavior or advanced SQL usage and therefore aggregation, it's likely to be placed into a circumstance where we would be applying it after the definition of the view. So we don't need to add in those things. What we tend to find ourselves doing, however, most often as an expression, are calculations around the data, calculations and concatenations and derivations of information. And here in the statement that I've got in front of you, where we've got select date diff date oppo opened get date, we can see an alias has been used, and this is telling us that the oppo days from opportunity becomes a column that would be referenced. Now in the next lesson, I think it's the next lesson, or it might be no, it is actually in 2 lessons time, we're going to look at the construction of a view around the case list area and seeing how derived fields can be made to behave as though they are entirely Sage CRM views. We can actually not trick Sage CRM, but we can certainly get it to consider itself as a very integral part of the system. Now, one of the mechanisms that we can use is, and you'll notice that a lot of the slides that I've been using have been using lead views because they are relatively straightforward. And this V summary lead is a nice view because it shows the good structure of a concatenation, making use of some database functions. It is always a good idea when you are wanting to create your own view to start at an existing location and then move on from it. So in the case of this particular view, so I can come into administration customization lead, I can look to this existing view, V summary lead, and copy it. Now we don't have a clone view feature. I think personally that would be a very useful thing, but it's easy enough to just select the SQL statement that you want, to then return to the listing of views and to create a new view. So if I call this V Jeff's leads, we can see that it's easy enough to create, and actually before I just simply paste it in like this, I could have pasted it into my management console to see what it looks like in terms of the query by example screen. And this gives me a good sense of both how the alias is used, how all of these phone numbers are concatenated, and where the clause is being used to restrict the information returned. And all of this, it makes it very easy for us to say, well, actually, I want to change this a little bit further. I want to do this extra little bit as well. Okay. Now, I notice a question has come in. I wonder whether that's a list. You've asked Michelle a question about lists inside Sage CRM, about whether they're editable or not. Lists are mostly drawn from views. That's actually not the reason why they're not editable. They're not editable because we haven't designed them to be editable, and that's just one of the design decisions around Sage CRM. So when you look at a list of communications associated, that's not a good one. If I look at a company and then look at the cases associated with this, we see here we're not expecting people to directly edit the information in here. Part of the way around that is that, of course, we've started to add in the idea of interactive dashboards, which may include gadgets, which may include features such as workflow. So here, for example, I can now click and I'm starting to edit it, not admittedly within the list, but calling it swiftly from the list. That's returning it back into that location. Okay, let's see, before I go any further, am I where I am? Okay, now we've started to touch on a number of things. We're starting to get a little bit more complex in our understanding. This introduces and takes the idea of aliasing of columns and tables, and we can see that we have got aliasing of the tables used within this view. And this is important to realize that this is a real view within inside the system. So if I go into my administration screen, go into customization, go into looking in and around territories, this is where we would discover it. Now, it's not necessarily shown immediately through the interface, and that's fine, because many views inside CRM are not visible. They are just used by us implicitly as we work through the system. But it would be shown if we were to reference the custom views in here, and I go and see that I'm dealing with the idea of territory. And so if I look for territory, it will be one of the views that are shown here, and we can see that this is v territory name select T, and that's a nice one because it's showing us the use of, as I said, the aliasing of both the territories and the captions, and providing a shorthand way of identifying the information. And you can also see the way in which the wildcard is used with the like statement. Now, like is probably one of the most useful things that we can use with inside a view, especially when you're trying to return and create a data source where you're not entirely sure how somebody would have entered a particular string. It allows you to create fuzziness around the return of data. Fuzzy searching is used within the company name cleanup function of Sage CRM, and we can use some of those ideas with any of our customization as well. But you'll notice what else is within this particular statement is that not only do we have this fuzziness of liking whether territory is like, or the word is like territory %, but we can also put in a requirement, a logical and, which means that both conditions must be true for the data to be returned. So it has to be done. So cap deleted has to be null, in addition to which the caption name must be like territory, or must begin with the word territory, and in addition to which the caption code has to be the same as the territory caption. So it's very restrictive. 3 clauses have to be satisfied here in this particular instance for the data to be returned. We've looked at is null and like already, but there are others in which we can use. Now these phrases tend not to be used inside the views themselves. So if I, for example, look for between, we'll find that there are no default views within the system that make use of the between word. But it can be a shorthand way of retrieving information, especially when you're wanting to look for a range of information. So if I say select star from opportunity, where oppo forecast is less than 100, we've already used that as the basis of a view. But if I now say is, let's see, is between between 50 and 200, what's wrong with my between? Forecast. No. I'm suffering there we are. This is where it becomes essential to be able to look at the SQL between and look at the SQL operator, and you can see between value and. There we are. It's the brackets which is causing the problem. I was right, the brackets were wrong, which actually is one of the important realizations, is that there are some strict rules around the use of the operators within inside select statements. So where you've got a predicate like oppo forecast between 50 and 200, this is a logical statement and what needs to be applied. Typically you do it in the order of brackets, orders, multiply, actually divide, multiply, add, and then subtract if you are doing calculations. So that's the typical order that you would do those in inside our statement. So that was silly of me to have not got that. But we've got our select star from opportunity where offer forecast between those. Now this is good, and this raises the question of, well, what happens if I want to select other information where I've got logical behavior? So if imagine I want to create a view that only looks at customers and suppliers. So if I think about the companies that we've got, can I say something about where the comp type is equal to a customer and, or sorry, I should say, or the comp type is equal to supplier. I've got 2 clauses being applied here, and this would work. So I actually can see that I've got 393 records where they're either a customer or a supplier. But actually there's another way of working, and this next way of working is going to be slightly less efficient, because we can be cunning here again by relying on an indexing on the comp type, because it will look for all of the customers and then all of the suppliers. But if I say select start from company, I can say where comp type, and now I can choose to add in a list of values that are eligible for that field. And this is introducing the idea. So we had 393 before, we've got 393 now. So it finds exactly the same information, but you can see some people might actually find it easier to understand that this statement is indicating that these are the sets of values that are legitimate for the company type. We'll meet this form of statement much more when we come on to the idea of queries being used, not in views so much as in the idea of tab clauses. Because if I go and have a look here, what we'll find is that we've got only a few that are making use of the idea of ins within their SQL statements. So if I have a look here and drop that in place, we can see that in this we've got, in fact, the opportunity ID in is making use of a sub-select. This is another topic which I don't want to touch on just yet. It actually ties into the just one of the next things that we can say here about the exists, but I'm going to save that until we are talking about the slightly more complex queries when we're dealing with the nature of tab clauses and wanting to control exactly when a tab is present or not. So you see that we can use subqueries within the structure, and you can, and it's perfectly valid to use this within your view definitions as well. As you can see here, we can make use of subclause. Now, in all of the examples that we've done so far, is that we have actually implicitly started to deal with joins. And joins are something that some people can get quite frightened about. But actually, when we're working with a tool like this visual tool that the database provides, it's actually not that difficult. For example, I can start to be quite clever about designing my own view that will bring person and company information together. So if I bring in here my company, first of all, and then I look for person, what we can see is that the primary keys are very clearly identified within the system. If you're used to using other database systems, you might know that if you do this dropping in of the fields, automatically magical lines appear between the two tables. And this is because the database has knowledge of the way in which the fields are related. Sage CRM does not provide a relationship diagram within the database. It doesn't model it in the database, it models it up in the application memory. And the only permanent structure of that for that database integrity is held, as we would see, in the Hibernate structure or around the Java Tomcat stack. You're not going to directly see that, but that's where, that strict referential integrity is applied. And that's only in metadata. It's not even on the application data like this. We keep it very flexible because of the way in which we can't necessarily expect data to be in perfect state when it's come in from external systems. But here I've got my company ID and my person ID. If I want to relate the two together, all I need to do is drag. What I'm doing is, you can hopefully see the marqueing this across, dragging the company ID across to the person, and it's going to spring in and create a relationship. Now, the type of relationship that I've just created here is something called an inner join. It's expecting that for every row on the left-hand side, there will be a corresponding row on the right-hand side. That's quite important to realize that. That's for every company record, there has to be a corresponding person record. And what this will immediately do is find everybody who works for a particular company. And what it will also do is exclude anyone who is an individual, who is not linked to a company. So I can't expect this to pull back an individual. Well, this is the nature of the inner join. Now, if I just say I want the company name and I want the person first name and last name, this is not, by the way, in a legal view. One of the things that we're going to be meeting is, if we were to start dropping this into Sage CRM, dropping this into the company here, for our reporting purposes, we would need to make sure that in our view definitions, we included certain columns which are used for ensuring the security policies. We will again see this again in the next couple of lessons, but for now I'm just keeping it nice and simple. 3 columns selected from 2 tables, and if I return that, we can see that it's returning the people who work for the particular companies. And this is really good. So we've got 1,786 people in my system that work for companies. But how can I make sure that I also include the people that don't work for companies? And this is where it can get funky. If I right mouse click this join, we can now say we want to select all rows from the person. And at this point, this is going to become an outer join. If I click this, you can see that it now becomes what's called a right outer join, because it's right on the join between the company and the person. The table person is the right hand one in the relationship. So it's a right outer join, and it's saying that you will always include person information. So now if I query this, it goes from 1,786 people to 1,794 people. So there are some people who don't have company information. And that's all I'm going to say, because it can get start to get even more clever here, because we can start to say, well, what happens if company name is null? What you'll find is you're only retrieving the individuals. But that would be too clever, because in reality, if you only want the people who exist as individuals and not relate to a person, you wouldn't do this. You would just have the person that's here and say, I want the person ID, sorry, the company ID is null, and that would find the same information. Oops, I put that into the wrong field. Is null. And you can see that pulls back the same people because the company ID is not. Sometimes we don't have to be so clever in order to get the information. Okay, that's the thought about joinings, and generally it's an equality comparison between the foreign key and the primary key, typically on the nature with inside CRM as an inner join. But as you can see, outer joins are used as well. And it's worth going in to where we've got our definition here and using the phrases. If we've got to look at outer, we can start to see, and I've chosen the wrong button again. And if we wait for that to crash out of memory and run that again, you can see that we have got, we've got quite a lot of different views which are making use of the outer structure, whereas the majority will be using, instead of 17 views, we've got 48 which are making use of inner joins there. So it's more common to have inner join references than outer join. Okay, now we know about the tables with aliases. I've mentioned that earlier on. We saw a slide with that, so I'm not going to emphasize that. We've seen, if we start to put this all together, we can see that we can alias tables, we can alias fields, we can derive information and provide joins across multiple tables in order to provide the information that we want. The chief joy of Sage CRM comes from the fact that we can steal so much from the interface. We can go into a particularly useful view that we like, that is a system view, which we know, okay, it's used. If I change this, it's likely to be overwritten when an upgrade happens, but I need to have this information for my report, or I need to have this information for my particular customized mobile screen. What I'll do is I will take the particular field, whether it's company email like here, and I will just copy it and create my own new view that I can then tweak to add in the information that isn't in the original view. And it's such a useful thing to be able to do that. Okay, well, we're coming very close to the end of what we're saying, but amongst the last things that I want to mention now is the idea that what we saw earlier on when I was starting to write SQL in this context is that we're using the idea of a qualified reference. If we see inside my database server, I've got other databases. And of course, those other databases may actually exist on this server, or they may have been linked through to another database server. Either way, they would be accessible to me through the idea of a fully qualified reference. And if I start to demonstrate this to you, if I go and consider the company table, so I add table and think about company, within my system, I've got information from another database system. Right, let's show you what I mean. In my system, I've got a database called Panoply Tech. So if I do, please can you confirm that here I am definitely using the CRM database. So let's have the only statement in here is use CRM 7.3. So I'm originating this statement inside the CRM database. If I now say select star from, I can say I want to go to Panoply Tech as my database, dot DBO, as the database owner, dot contacts. Oops, contacts. And you can see by fully qualifying it, I can find the information that I want. Now, if I now take that and put this into the from statement, there'll be something of a conniption if I try and execute this SQL. What I mean by that is that it's going to try and create a join where no join exists. And you can see that there's it's trying to create what's called a cross join. A cross join is where there is no matching data. We've not created a proper join, we've just tried to reference those. Now, I want to say that there's a relationship, and between the two fields is that I've actually imported. This could be here an ERP system where I'm looking at an account system and CRM where the company name or the company reference is exactly the same. There are two fields which are the matching yin and yang, or the common key between the two. So I can look at my company name between the two. I can drag them across and I can look at them like this. And you can see there I've created an inner join based on the company name. And if I execute that, we can see that in my system I have got, what do you know, 16 records which exist both within inside the CRM database and inside this external database. I have got here I've got here some demo data that I've imported from my sample database into CRM, and you can see that I'm able to maintain a link. Now, if I just now say all columns from company, just to satisfy this, I can develop this still a little bit further, because what I can do is I can add another table and I can add in the person information. Let's just add in person. I'll add in the person information and join those two together. And I'll keep that to be a nice one-to-one relationship. So I am, where I select the person, there has to be the corresponding company as well. And I'll execute that SQL. And you can see I've got 17 rows now. So this is telling me, by the way, that I've got two people working for one company, because it went up from 16 rows to 17 rows, because I've added the person in here. But this now is the basis of a view that I could use if I want to switch over to look at my company again, to create a view. And I could say that this is going to be a view here, which I'm going to call the Panoply Tech Contacts. And I paste that in here, and I'll say that this is useful for reports, and I'll choose Save. And I can now go across into, as a user, into reports, into general. I can create a new report, and I can look at here, and I should be able to see I've got my, somewhere in here, the Panoply Tech Contacts, and in fact, there we are. We've got the company information that we have got. Let's bring in the company name, and let's bring in the person name as well. Let's first name and last name into the contents. That's all I'm going to do here. Let's call it a name and say this is Panoply Tech Companies. I continue, save, and this is the most boring report that I've created ever, but there's my Panoply Tech companies. If I run this report, what we will see, and let's actually prove this, that it's not erroring. So if I go into my general reports as a user rather than the system administrator, because you should always test as a user, not as a system administrator, as I will be emphasizing in 2 lessons time. But here you can see there we can create our report. I can run that report, up it pops, and this should, and of course the reason why it doesn't show me any data, because they're all in the wrong territory. That was brilliant of me, but it does run. It does run. It applies the security policies, no error, because I can return back in here. I can run that on screen, and up it pops, and it should show me the 17 people. I'm very politely trying to translate the page as well. So I've got my ability to bring in information from those external tables that sit outside of CRM, fully qualify, make it available for the CRM database for reporting, graphing, inclusion as a database source, as the basis of an interactive dashboard gadget. And of course, then into the mobile screens, because if you can create a view, you can create a list block and a screen, and they can be shown within inside a mobile gadget. Okay, now I've come to the end of this session. I'm going to just switch over and see whether anyone has got any questions at this point. I see that there are some, but I do need to end the recording at this point right now. So I'm just going to do that. Thank you for listening.